Hello everybody. So the first video that we're going to be covering is regarding functions. Now remember when we talked about functions, we called them subprograms. It's another way of looking at it. It's just saying that they're a self-contained program within a program. So first let's talk about why. Why would we create our own functions? Well, when we were talking about our strategies for developing software, one of them was the divide and conquer strategy, which I think is the most, a function is the most clear-cut way of getting to the divide and conquer uh, strategy for creating a program, because it allows you to take a big problem that is very complicated, break it down into a whole bunch of smaller problems, write functions that solve those problems, and then simply call those functions, assemble it all together, and you have your program. Now, what goes with that is, of course, it also simplifies your programs in general, because you don't have to repeat code. If you wanted to do something multiple times, you just call a function multiple times. So if your function is doing something really complicated, rather than writing that complicated thing out twice in your main program, you write it once in a function and call it twice. Now, what about how do we define and how do we call a function? Well, we've already been doing this, really. The function call, an example here is us using the pow function. We've used the pow function a few times now. It allows us to raise a base to an exponent, right? Or raise it to a power. Now, this function was not created by us. This was given to us by an external library, and it takes two parameters or arguments and gives you a result. So this calling the function causes the function definition to be executed. So we don't know what the function definition is. We don't know how they implemented the pow function. I'm sure we could find it online, but that's not important. We don't care. We just care that it gives us the correct result. And the other important thing is we can call this as many times as we want. And again, we don't even need to know how it works in this case, but when we write our own functions, it'll be useful because we can just call it many times. We'll know how it works, but we can call it many times. Now, the function definition. So the function definition. The function definition is comprised of a few things. I just want to cover this, and then we'll actually look at it, and it'll hopefully all come together. So the first thing is we have a return type. So return type is just the data type of the function, or what it will return. We've talked a lot about data types, and all of them still apply here. We just have one additional data type that we're going to talk about here in a minute. Next is the name. Just like a variable name, a function name is very important, and we should use descriptive names so that when we call the function, our code becomes a little self-documenting. So, for example, the pow function is pretty useful because power, it raises a base to a power, very descriptive name. And we want to follow the same path that they have and make very descriptive function names. Next, we have what we call a parameter list. This is data that we send to a function. This data that we send to a function allows us to change the inputs of the function so that we get different outputs. It makes our function a lot more useful. So we can define let's just say a formula such as raising a base to a power, talking about the pow function again. We can change the parameters that we're sending into it to change the result. Next, we have the body. The body is the statements that make up the function. So when we make a function, we're going to be using C++ statements to define the body of the statement, or just these are the steps that you need to do in order to execute this function. Lastly, we have function header, which is just the return type, name, and parameters, the parameter list, all put together. We call that the header. Okay. Now, when we're talking about the function data types, they're all the same ones that we've already covered, int, float, double, etc. But the only exception is that we have a new one called void. What's the reason for this? Well, the reason for this is when we get into talking about the data types a little bit more thoroughly, we talk about a function can return something. So the POW function returns a double, like we talked about in class, right? The POW function returns a double. So that means that the function's data type is a double. But not all functions we want to return some value. Sometimes we just want to call a function and have it do something but not return anything. That's why we introduced the new data type of void. Void is kind of like the absence of a data type, but that's not entirely true. But to simplify it, I might talk about it like it is the absence of a data type. Just know that that's not entirely true. Void is itself a data type, so it's not a lack of data type. It is just a, a way of expressing it. Okay, so everything that's not a void function then has to return some value. It has to return some value that is the data type that the function is. So if it's an integer function, we have to return an integer. What we call this is single value returning functions, or SVRFs for short. So keep an eye out for that acronym. Now, a single value returning function just means we pass in our inputs, call the function, we get a single value back. So, like I said, it's any function with a data type that isn't void, and it returns a value to the caller. So just like the POW function, boom, we say base of 2, exponent of 3, we get our answer returned to wherever we called it. If we want to store that in a variable, we can store that in a variable. If we got the POW function inside of a mathematical expression, the whole expression will be evaluated. We can use it in many ways. Now, this is also the most common type of function that you will use, besides maybe a void function, but single value returning functions are probably 90% of your use case. Okay, let's look at our first example here. So our first example, I have created a function that I have called print greeting. So this is a void type function. So it goes in the exact order which I explained the function definition. We go in that order. So this is the return type or the function type, and this is the function's name. And then we have a parameter list that would go between these two parentheses. Now, this function does not take any parameters. It just does a cout statement, so it doesn't need any parameters. We'll get to that, though, but that's where it would go. It's right here. Now, this whole thing is called the function header. Everything between the two curly braces, this is called the function body. So these are the statements that make up what it means to print a greeting. Now this whole thing is the function definition. So when I say the function definition, we're talking about the whole thing. What's the data type? What's the name? What are the parameters? And the body of the thing. So you'll also probably notice, well, first let's run this and let's see what it looks like. So I'm just going to run this first. Hello, welcome to my program. Okay, so if we look at this, control goes into main, it executes this function. Now what does that mean? That means that control is going to go up here, start here, go into the function, and it's going to run this cout statement. And then there are no more lines left in the function, so it will leave, come right back to where it left, and then execute the next line. And so it'll do a system pause. So that's exactly what's happening. But let's look at it in the debugger. So if I just hit F5 instead of Control F5, Control gets to this line and we are paused. Now, before I was saying, oh, you're probably just going to use this step over button when you're debugging. Well, now is going to be the first time where we're going to see why we actually might need to do a step into. So if I do a step over, It just went right over the function call. That's interesting. So that's what step over does. It'll step over any function calls and just go to the next line. So let me stop this session and let's go back because I want to get it to debug into the function. So if I hit F5 again, you can see the little arrow. This is the line that we're paused at, and I can click step into. When I click step into, now control's right here. So now if I step over, I can see, oh, there's the cout statement. So I step over. Now we're at the end of the function. And then if I step over again, control goes back to main, and it's going to execute the system pause next. And then if I click next, we'll be at the press any key to continue. As soon as I do that, return 0, the program is done. So I can just click continue. Now, a question some of you might be asking right now, which is a very good one, thank you for asking it, is why is your function up here? Why can't we just move this, after main? It seems like it's cluttering to have it up there. So let me just cut and paste it down here, and let's run this program. Uh-oh, there were build errors. No, we don't want to run the last successful build. Print greeting identifier not found. That's interesting. So what the issue here is, you know how we need to define our variables before we use them, right? We have to say int some number equals some value before we use it. It's the same thing with functions. So technically, when C++ is going through and it's scanning this file, what it's finding is, oh, print greeting, you want to use this function? I have no clue what this function is because it's down here. It starts at the top of the file and goes down. So, in order to get around this, we have one more term for you to know about functions, and it's called the function prototype. So I'm going to write up here function prototypes, and we will paste our prototype up here. Now, your function prototype is going to be the exact same thing as your function header. Difference is, just follow it with a semicolon. That's all that you need to do. Just take your function header, copy it, paste it up here, put a semicolon. Now, when I run the program, it works just fine. Now, functionally, these are equivalent. If I put this back up here, it's fine. It's the exact same thing. We can run the program, nothing changes. Now, if I undo this and go back to the preferred way, this is the preferred way because it allows us to organize our application a lot better. It allows us to put, here's everything that the program is doing inside of main, and then all of our function definitions are all at the bottom of the program. They're out of the way so that they're not cluttering our view of the program. And then we just have to list our function prototypes up here, which doesn't take too much room. And we're good. We're nice and organized. Okay, so next let's take a look at a function that will square a number. So I'm going to come down here and let's just say it's going to be an integer function. So it's going to return an integer that is the square of another integer. So my function data type is going to be an int because we're going to actually return an integer, and I'm just going to call this square int. So there's nice and descriptive. Open and close parentheses. Now, do we want to pass it any parameters? I want you to really think about this. Do we want to give it a number to square is the question. And hopefully the answer is yes, because we don't want to just square some random number and return it, because that's not very useful to anybody, right? So we're going to type int, because we have to define the data type within the function definition, okay? Within the function header, excuse me. So I'm going to call this number to square. And then all we need to do now is give ourselves a function body. Cool, we have this all set up now. Now before we go any further though, I'm just going to take my function header here and make my function prototype so that it doesn't complain about that later. Now, how do we square a number? Well, we just multiply it by itself one time. So let's do that. Int answer equals our number 2 square times our number 2 square. So answer technically contains the answer to our function. So next, we have a brand new keyword here, return answer. Now, what does return do? Return immediately stops a function. We see return here when we're talking about main, and that says, when we talked about it, we said that this is telling the operating system 0, nothing happened, there are no error codes to send back, everything went fine. Okay. Just like in int main, our function has a return as well. Now, not all functions need a return. Like, let's look at print greeting. Print greeting, technically, it just executes all the lines of code and then exits when it gets to the bottom. That's perfectly fine and perfectly valid. But, well, that's only perfectly valid if it's a void function, because we don't need to return anything in a void function. Well, not only do we not need to, we can't return anything in a void function. This is an int function, though, so that means we need to return an integer. If we don't return an integer, that's an error. It won't even compile. So here's how we return something. Now, when we do a return statement, even if we did have another line down here that was like answer equals 1, and then we save it, this line of code will never get executed. In fact, it'll even give you a warning about it when you're trying to compile. So, because as soon as we hit this return, it sends this back to main, and that's it. That's the end of the function's execution. Okay, now let's remove this print greeting and let's call our square int. So I will do a cout statement, and I will do 2 squared equals, and then I will call square int open parentheses, just like POW, just like all the other times that we've used functions. We see IntelliSense is telling us a nice little bit of information here. It says this is an integer function, so we're going to get back an integer. It accepts one parameter, or one argument in this case, number 2 square. We pass our argument, and then let's do an end line. And let's see if we get the right answer back. So I'm going to run this really quick. And we see that 2 squared equals 4. That seems good. Seems like it works. Really quick, let's just change it to a 3 just to make sure. So 3 squared, we should get back 9. And we did. So everything looks good so far. Now, when there's a few more things that we need to talk about with terminology here, and specifically regarding sending data to functions. So when a variable is passed into a function when calling it, we refer to this as an argument. So in the example that we just did, when we called square int, we passed 3 to it. This would be called an argument from this perspective. So we're passing in 3 as an argument, the first argument. Now, variables that receive those arguments are called parameters. So if we look at our function header, we can see that we have int number 2 square. That would be called a parameter. Okay. Sometimes people get these conflated. I'll even get them mixed up and call an argument a parameter, but just make sure that you know the difference and that there is a difference. And let's go to another demonstration. Okay, so I've cleared out all of the changes that we did earlier, and we're going to create a function that we can pass a name to, and it will greet the person using that name. So whatever else we're doing around the program, not an issue. We're just going to take a look at the function itself. So first off, are we going to return anything with this function? No, I think we're just going to write to the screen and not return anything. So since we're not returning anything, what should be the data type of this function? Well, it should be a void. So we're going to do a void. I'm going to call this greet by name. to make it more descriptive and say, hey, we're going to pass in a name. This isn't just a normal greeting. And we need to make sure that we include string, because we're going to be using strings. Now, we come in here and we're going to say, so string name is what we're going to pass in. So this is our first and only parameter that we're going to set for this function, is the name. Now, in the function body, we are going to just simply cout good morning. And then let's put in the person's name, just like that, and then a nice end line, and that's it. So now we've created the function. Let's not forget about the function prototype up here. Now, when we're in main, we can just do a greet by name, and let me pass in my name, and let's see what happens here. Perfect, exactly what I wanted. So, now let's take this one step further, and let's say we don't know the person's name. Let's declare a string username, and then let's cout, please input your name. And then let's do a cin of username. And then now let's print greeting with username instead. Let's see how that comes out. So it's asking me to please input my name. So I'll put Dan. Good morning, Dan. Ah, that's nice. Okay, so let's try it again though. And let's say Chad. So please input your name, Chad. Good morning, Chad. So see, it works no matter what, and I can remove this cout here and instead just call greet by name. Very simple example. You're not saving yourself any lines of code necessarily here, but let's move on to something that you would save at least a couple of lines with. Okay. So I'm just going to pause it here for just a second, just to give everybody a chance to, if you wanted to copy any of this down or take notes on any of it, please do so now. Okay, so next, got an idea to do this from the book. Now the book had an idea for an app that converts cups to ounces. So if we did create an app that converts cups to ounces, we're going to have to ask the user how many cups do they want to convert, and then do the conversion, and then write that to the screen, right? Well, let's start off with making ourselves a function that converts cups to ounces. So the first thing, we're going to use doubles, going back and forth. So we're going to ask the user for cups as a double so that we can do fractions and all that. And we're also going to return fractional ounces, so let's use double. So our data type for our function is going to be a double, because that's what we're going to return to the user. Now, let's call it convert cup to ounce. Getting a little long, but very descriptive, so I like it. Now, the first thing that we're going to accept is double and cups. So that's the number of cups that they want to convert. Now, let's declare a double answer to store our answer. And then next line, let's do answer equals, and then the conversion from cups to ounces is just to multiply it by 8. So we'll do cups times 8.0. So remember, it's a double by default, so there's no coercion happening here. So now answer contains the number of ounces for the amount of cups that the user inserted. Now, we're just going to return our answer, and that should be it. Now let's just grab our function prototype, or our function header, and make it the function prototype. And don't forget, you've got to add that semicolon for the function prototypes, but you don't add the semicolon for your function header. small nuance that's going to trip a few people up, so I just want to be extra clear about that. Now, coming back to main, let's write something to the user. Let's say what amount of cups would you like to convert to ounces? And I'm going to do an end line here, and I'm going to make a note. Note, 1 cup equals 8 ounces. Just to make sure that they know that. Now let's come up here, let's do a double, and we'll say cups, ounces, so that we got a double variable for both cups and ounces ready to use. And we'll say cin cups. Now, how do we get ounces back? Well, we're going to say ounces equals convert cup to ounce, and then open parentheses to call the function, and now we need to pass in our argument of cups. So now, when this function evaluates, cups will get passed in here. We will execute the body of the function. It will return an answer. And you can think of it as this whole thing getting replaced with some number. Like if the user inputs 1, it'll do 1 times 8.0 returns 8. So you can think of it as this whole thing getting replaced with 8.0. So let's go back here. Now this return value is going to get assigned here to ounces, and it's going to be stored. So now what we can do is we can see out cups, number of cups equals ounces, number of ounces. Oop, need another insertion operator there. And one more for an end line. And now let's see if our program works. Let's just run through it really quick one more time. So we have cups, we have ounces. We're going to see out how many cups would you like to convert to ounces. Adding our little note there so that they know. And we're going to see in our cups, convert cups to ounces, store that in ounces, output cups that they passed into us, and then say number of cups equals the ounces that we calculated, number of ounces. Okay, so if I input 1, I should get 8 back. That's a good test that we can do. So there we go. There's our input. 1 number of cups equals 8 number of ounces. That seems to work. Now you see that we saved ourselves a couple of lines of code with this, but what if we wanted to, like this right here? This is the prompt for the user. This is the prompt for the user, right? This tells the user, hey, this is what we're wanting you to input here. What if we just took this out? And what I mean is, what if we took that out and we made it into a function? So we're not gonna return anything. So we're gonna have a void data type for this function. We're gonna call this print prompt. And we're not going to pass in any arguments because nothing will change, and we're just going to paste our cout statement there. Now let's take that function definition and come up here and make our function prototype. Now if I run the program now, you'll notice I didn't call the function, so it's not printing anything, but I can input a 1 and it tells me everything. It still works. It's just not prompting the user before we're getting input from the user. So what we want to do is we just want to call the function print prompt. Whoops. Now, when we invoke this function, it's going to come down here, call this cout statement, and it will be printed to the screen. Nothing will change, but our program just looks a little better. So we don't have this really big cout statement cluttering up our main part of our program. And you can see that we can do this with basically everything. It's not always a good idea to make everything into a function, but some of the things that get more cluttered, you can definitely make an argument for making a function for. All right, so again, I'm going to just sit here for a minute, let everybody take notes about this program, and maybe even get caught up if they were trying to type along with us, and then we'll move on to our next demo. Okay, so for the last demonstration for this section, I really wanted to do something that was a Boolean single value returning function. So what I want to do is I want us to make a program that accepts input from the user and tells the user if the number that they inputted was either even or odd. Now, how can we do that? Well, we talked about in class the way to determine if a number is even or odd is by doing a mod 2 and determining if that result is 0. So if you divide a number by 2 and there's no remainder, then by definition it's an even number. If you mod 2 a number, that's exactly what you're getting is the remainder after dividing by 2. So we can say that if you mod 2 and that equals 0, it is even. And if you mod 2 and it's not, then it's definitely odd. So let's go with that. So we want to make a function that when we pass in a number, it will tell us if it's even or not. So if we're asking a question and it's true or false, that means that we're asking it a Boolean. So this function is going to return a Boolean answer. So let's call this bool for our function data type. And let's say is even. So we're asking if this is even. And let's say int number. So we got one parameter so far, and it's just a number. I think that's all we need. So we know if statements. Let's start off with a bool, and let's say that this is answer, and let's assume that it is false, that it is true. Let's assume that it is even. And we'll just say, well, if it is not even, we'll set answer to false. So how do we determine if it is not even? Well, if number mod 2 equals 1. So if number mod 2 equals 1, then we know that the number is actually odd. So let's say answer equals false in this case. And then here at the bottom, we're just going to return answer. So walking through this really quick, if we pass in the number 2, we're going to set answer equals true. Okay. And then we'll say number mod 2 equals 1. The answer to that is false because 2 divided by 2 is 1 with no remainder. So remainder would be 0. So 0 equals 1. We do not go into the if function, so we skip around and we just return answer, which is true. Now let's look at it for the number 3, which we expect to get false back from. So 3, answer is true. 3 divided by 2 is 1 with a remainder of 1. So 3 mod 2 ends up being 1. Does 1 equal 1? That is true. So we go inside the if function and we execute this line of code. So answer gets false. And then we return answer, which is false. Exactly what we expected. So I think that this function will work for us. So let's go ahead and copy this and not forget to do our function prototype here. Now let's start making the part where we interact with the user. So let's see out. Please input a number. Oh, we gotta declare a number. I'm just gonna call this input number. Now, when we get down here, we're gonna do a cin, and we're just gonna get input number. And then now what we're gonna do is we're gonna do another if statement. So we're gonna say if is even input number then let's see out the number you entered is even. Now we can also write an else statement here. Oops, excuse me. Let's do this. We're going to see out the number you entered is odd. So we're asking the user to enter a number. We get that. Then we get that number. Then we say if calling our function is even, which returns a bool, the input number. If this is even, is what we're saying here, then execute this code. That just outputs and tells the user that it's even. Else, the number you entered is odd. Okay, let's try it. Please input a number. Let's say 6. The number you entered is even. Well, that's right. I mean, I agree with that at least. I hope everybody else does too. Whoops. Now let's try 7. The number you entered is odd. Perfect. That's great. Now, something that I've been just glossing right over and not really fully explaining, and I really want to take the time now to do that, is let's talk about the scope. So when I say input number is a variable defined here in main, right? It exists between these curly braces. This has to do with scope. So when I pass this in here to this function as an argument, when we come down here and we see the parameter is called number, just because I'm passing in a variable called input number as an argument and the parameter is called number does not mean that this code doesn't work, because we don't mention anything about input number here. No. What actually happens is what we call pass by value. Pass by value means that it's going to take this input, make a copy of it, and that copy is going to be called the parameter number. So once we get in between these curly braces, everything, that integer that you passed in will be referred to as number between these curly braces only. And since we're making a copy, if we did something crazy, like say assign number a value, this number change will not affect this number. Okay? So if you change a number in a function, it won't change a number in the main part of your program. Now there are ways to do that, to change that, but we'll get to that much later on. In the meantime, let's go to talking about pass by value in a little bit more detail. All right, so I have a simple example here that's roughly the same thing that we've been that we just did with the is even, and I apologize for the handwriting. Trying my best here with the computer. So we have our int main that has an integer declared my num equals 7. So right here we're going to write up here my num, and we're going to make a little bucket for it, and we're going to say that it has 7 in it right now. Now when we get this, and we are calling if is even my num, just like we were doing in the demonstration program. This my num gets copied and passed to the function here is even. So if we look over here, is even is defined int num in. So this value right here, num in. Now, my num is going to get copied to num in. And num in is going to contain a copy of the number 7. Now, hypothetically, if we came in here and declared num in equals 0, for whatever reason, we're just modifying some stuff. When we get to this line, what's going to happen is num in is going to change from 7 to 0, but it does not change my num here. And that's very important. Since we are sending a copy in, it's only going to change it within the context of these curly braces. Now, when we get done with this function and we get to the bottom and we're at the ending curly brace here, what happens is this variable actually is just destroyed and returned back to the operating system as memory. So that all just goes away. And now when we come back here and we go, let's just say we go inside the if block, my num is completely unchanged and num in does not exist anymore. Okay, so for the next little demonstration here about passing by value, I wanted to cover an odd scenario. It's not something that you would normally do, but let's take a look at it. So I've separated it into left and right, so don't let that confuse you. But here's our int main, and so we declared int myval1 equals 10. So myval1, the first thing that we're going to do is assign 10. Next we do int myval2 equals 12. So we assign 12 here. Now, when we're passing these arguments in, we're passing in myval1, then myval2. This is the first time we're looking at a function that has two parameters listed. So there's int num1 and int num2. Now we're passing them in, so myval1 is first. It's the order that matters here. So myval1 is going to become int1 once we copy it into the function. So num1 ends up being myval1, which is 10. So 10. And then next, our second parameter here, our argument is myval2. Myval2 is 12. So num2 ends up being 12. Okay. Pretty good so far, right? It's the ordering that matters here, so make sure to keep that in mind. Just because if I swapped these around and I said myval2, comma myval1, it would absolutely change the order of these. So num1 would become 12 and num2 would become 10. The names do not matter when we're passing these in. So just remember that the names do not matter. The order is what matters. Okay, so first thing we do when we get into this function is we declare another variable called temp. So we'll declare a temp, and we're assigning num1 to temp. So num1 is 10, so temp becomes 10. Okay, now when we get here, we assign num1 equals num2. So num1 is 10, and it gets num2. Num2 is 12, so num1 is now 12. Next, we get here, num2 gets temp. Num2, 12, gets 10. So all we did is just swap these variables around, right? We've seen this before. We've done this before, swapping two variables. We're doing it in a function now. And I'm doing it in a function because I want to prove a point about now we're here. We're at the ending curly brace. So now control is going to go back to main. And if we had our return 0 here, we would execute that next. So we have our return 0 here. What is going on here, though, with these variables? Nothing. Nothing changed. Just because we swapped the variables over here doesn't mean that the variables get swapped over here. These are not going to be equal, okay? They're not going to be equal once we pass them in. This is what it means to be passed by value. Later on, we will talk about another way to pass variables in, but for now, just keep in mind, this is the way that we're going to be doing it.